Hi, I'm Mark Verbos from Verbos Electronics, showing two new modules at the NAMM show today. The first of those is the Sequence Selector, which is a 5-stage analog sequencer with gate output, gate switch control, CV slider, and two 5-to-1 analog selectors with a gate input to select stages and a button on each stage. This can be used to expand on the existing sequencers that we have, the voltage multi-stage. By patching the CV output into the transpose input and then into an oscillator. It can also be used to multiply the number of possible rows of control voltages from sequencers. For instance, in this case, we're using the eight stages on the top row and then the 8 stages on the bottom row by using the analog selectors, and that could be done with as much as 5 external sequencers that selected between this. Also has a selectable gate output, so some other tricks can be used. Oh, wrong one. What does that know? Okay. The second module I'd like to talk about is the random sampling, which is kind of a riff on the source of uncertainties that VUCA did in the 70s. It's several sections. The first is 2 fluctuating random voltages, which are voltage controlled, slowly varying random voltages. This is an early prototype. It will have much more range. Right now, the range is similar to what's actually in the VUCA 266, but we're going to get this to go up into audio range too, so it can be used as a variable noise source. It has also, in addition to the CV output, it has a gate output that happens in that is correlated in speed but not correlated in voltage that can be used as a square wave random modulation, or as a gate to trigger random patterns or not patterns, trigger envelopes or sequencers. The next section down is the quantized randoms, which also comes from the VUCA source of uncertainties. That it's actually a 6-bit digital selection of voltages with control over how many of the bits are active at any one time. With the quantization control all the way down, only two different voltages are selected from. And up at 6 bits, the 2 to the n would be 64 possible voltages, and the n+1 would be 7 possible voltages. The difference here is that it's truly random. There is no repeat to the sequence. It will always be different every time. You're only controlling the number of possible states, not the length of a sequence, because there is no sequence. It's truly random. Then a noise source, white, pink, and metal or metallic, which is 6 detuned oscillators, similar to the noise that's used to make the cymbals in a TR-808. And then a 4-stage analog shift register. The analog shift register. The analog shift register is a bank of sample and holds that are in series, so that voltages coming in are stored in the first sample and hold, and then on the next pulse moved to the second one, and the external voltage is stored on the first one. And this is useful in some sorts of musical situations where you want to essentially echo the control voltage from one voice to the next. But this implementation actually allows the sample and holds to be broken out of the equation and used as separate sample and holds. So if the user wants to have a 3-stage analog shift register and an independent sample and hold, that's possible, or 4 independent sample and holds, or 2 sample and holds and 2 in a shift register, whatever you want. And because the logic of the analog shift register is actually based on a very short delay of the trigger, triggering the last one, and then the second to last, and then the second, and then the first one. If the same voltage is sent into all of them, and then the master trigger is used, it doesn't actually show up as the same voltage on all 4. So then they can be used as analog uncorrelated varying voltages as well. Maybe kind of hard to see this in well, you can't see it, but with the same voltage going into them and using the master trigger, it's a random collection of choices. So that's it. That's what I'm showing at NAMM. Thanks for watching.